Hello, everybody. I think we'll start the webinar. Welcome to you all. Good morning, good afternoon, good evening, wherever you might be. The next hour is going to be an ambitious three-way webinar between ourselves, our friends at Metis and our friends at Roland. The primary objective of our presentation is to show you how the three technologies work with 3D data, from the scan through to editing through to digital output. But of course the technology can be used for 2D. So if anyone's tuned in to see a bit more about 2D scanning and editing and printing, these technologies can be used for 2D. The flavor of the webinar is wood decor. And with this primarily for flooring and decorative surfaces. We're going to be showing a whole range of different techniques which are quite unique to the market. Hopefully you're going to tune in to see some exciting innovations. You can, of course, ask questions at any time. We hope to finish 5 minutes early to allow a little bit more time for more in-depth answering of questions, but feel free to use the Zoom chat and the Q&A within Zoom. I believe some of the questions can be directly privately to the panelists or open forum. So feel free to answer. There are lots of us from Metis, AVA and Roland in this session, and if AVA is doing the presentation, one of us can answer the questions in the background. As you can see on the slide here, this is the general workflow we're going to give you a flavour of. There'll be contact details at the end, but I'm now going to hand over to Massimo of Metis, who's going to give you an introduction about the Metis technology and the Metis company. Thank you.
Good morning, everybody. Let me share my screen. I hope you can see it now. So again, good evening, everybody. My name is Massimo Colombo, Metis Sales Manager. I will give you a brief introduction of our company before listening to our technical expert, Jürgen von Kanen, that will do the technical presentation. So, a few words about our company. Metis is, of course, is a scanner manufacturer, Italian company based in Rome. Our headquarters is in Rome, and also our demo facility is in Rome, where we are showing all our current scanner. And our production plant is in Tuscany. Well, of course, I wanted to thank our partner, AVA and Roland, to have arranged this webinar, and all the participants to the webinar, and a special thanks to the Metis client that are participating. I've got many emails saying that they were participating, so thanks very much for joining this webinar. Okay, now to continue. So I will not bore you with all the story of Metis because it's a long story, but there are a couple of points which are very important to us because in Metis we continue a family tradition of industrial designer that started almost a century ago. And the founder of the company, which started his career in '65, brought a lot of his fantastic experience in the photographic scientific application and remote sensing and satellite imagery. He was consulting for 25 years with European Space Agency. So all this technology has been brought in Metis, and the Metis R&D team has developed that. So you will see from the timeline while I'm talking all the type of system that we have been manufacturing. So Metis was created in late 80s, and for 15 years we have been developing system and giving solution to the cultural heritage field for any type of archive, library, and museum that had any needs to scan their patrimony. They were using our scanning. So we can count actually on big names like the Vatican Library or the Library of Congress and more than 200 institutes all around the world. So we have been manufacturing all this system through the time, And actually, in 2009, we decided to enter also the market of the industry. So we have to redesign the light, because that was crucial for us to have a completely different light from the application in the cultural heritage. So we made a patent, which is the DCS synchro light. And so in 2010, we started with this complete new redesigned system entering the market. And actually, in a few years, we got really the best possible client in all the industry like ceramic, industry like wallpaper, wood panel, flooring, fine art. That was also thanks to our partner that, because, apart from the demo facility that we have in Rome, we can also count on demo facility in USA, thanks to CGS, which is our partner there. We can count on 2 demo facilities in China, thanks to our partner Cytoprint in Shanghai and Foshan. And we can also count on a demo facility in Tokyo, thanks to Toyotech, which is our partner in Japan. So we have been continuing developing new system and new application. We moved in 2016 to a new factory, as I said before, and we had a new sensor on the DRS family 2018. So, but the technological milestone for Metis was between 2013 and 2014. In 2013, Metis started as a first scanning manufacturer to use the 3D photometric stereo technique, which is a technique that allows accurate 3D data for engraving and embossing application. And as you will hear from Jürgen, that is applied in the industry using directly our files to engrave, or to use for AVA, directly the 3D for AVA, or for Roland to print out the 3D, the texture. And for many years, Metis has been the sole scanner manufacturer to use this master technique. Then in 2014, very important, we made the Metis SuperScan PM3D. We launched it in the market. And actually, this is patented protected because it's a very, very special technology based on an innovative design adopting for the first time a telecentric lens instead of the standard optic. The PM3D provides unique performance that really doesn't fear any comparison in the market. To have a quick look to the scan that we offer to the core application industry today, again, the Metis SuperScan, patented protected, the DRS 2020 DCS, which is the most sold in the DRS family to our client base, and the DRS 1520, which is adopting the same type of technology of the DRS 2020, it's just a different size, a smaller size. Last but not least, the SUR 3D, which is our entry level, which is very fast and easy to use, completely automated, good color and 3D data, still using the photometric stereo, and can be used to color profile a printer. Thank you very much for your attention, and now I pass the word to Jürgen. Thank you.
Hello, everybody, and thank you, Massimo, for this short introduction. Massimo asked me before I start the presentation for the webinar to tell a little bit about myself, my past, and what I do today, for example, as a senior technical specialist from Metis Systems in Italy. I will gladly do that. For this, I will share my screen with you now. So, my name is Jürgen von Kannen. I'm a technical designer. Design and technology always fascinated me, and I'm always looking for innovation in design processes. That has shaped me and my way of working. I want to tell a little bit, very compressed, I swear in under 3 minutes, about my past. I have 35 years of experience in 3D modeling and also in advanced 2D image processing. I was the founder of the first computer graphic studio in Germany, where I specialized me in high-end composings for technical products and process visualization. My studio got a lot of appreciation in publications like Novum, Computer Art Fascination, Reader's Digest, and so on. In 2008, the owners of Ungricht, world leader in industrial engraving, asked me for help in redesigning their design studio and optimizing their 3D engraving data. In 2009, Ungricht was, with my help, the first engraving company worldwide with a complete 2D, 3D design creation workflow. Between 2012 and 2014, I was looking for advanced 2D, 3D scanning technologies for this company. During this time, we had all available scanners on the market from all manufacturers, including today's competitors of Metis, to compare the technologies with each other. So I found the scanners from Metis systems in 2013. In the same year, we installed the first Metis DRS 2000 system at Ungricht. In 2014, we installed the second scanning system, the flagship of Metis, the PM3D. It was the first installation of this scanner worldwide in the decor industry. Between 2013 and 2014, I was involved in this development of this still unique scanner for decor application. Today, I'm a consultant for IT and especially therefore image processing technologies. I give also support in design creation, especially technical design. And today, the innovation management is also a part of my portfolio. In the field of 2D, 3D scanning, I'm working exclusive for Metis systems in Italy. So I think the audience now understand why I'm doing what I do today, and that it is a great motivation for me to help customers worldwide with their processes and their problems and to find appropriate solutions for them. We don't have much time here, so I'm going to cut the chase and start my presentation for today's webinar. I would like to introduce you today to the part of a workflow within a decor reproduction that deals with the scanning and preparation of the data required for this. In this case, we are talking about printing and embossing data for a 3D prototyping printed on a Roland DG multipass printer. For our test production, we use a typical material for decor application, some wood planks. To control the scanner, we use the Metis Scan Director software. After the material has been prepared, sometimes the planks are bent and this mistake must be corrected. The original is carefully placed on the scanning table. For your information, this industrial scanner is able to scan originals up to a weight of 200 kilograms or 440 lips. In this case, we acquire the color and the 3D depths, and we do it with the greatest scanner in our portfolio, the Metis PM3D. You see here the interface of the Metis Scan Director. In the Metis Scan Director, we have the possibility to control the scanner hardware. Here we crop where we want to scan, make 600 ppi, it's enough for digital printing, and say make a super scan. Now we see the calibration. It's a 4-pass super scan. And now you see the scanner hardware. The bridge here with the head, for your information, has a weight of around about 500 kilograms. In this head are 8 lights for soft and for hard lights, so we can adjust the casting of the shadows to get any appearance we want to get. Here we see a little zoom on the original material, and now the scanner head is going on here. So, before we talk about optimizing scan data with our software Metis Light Inspector, I want to explain the different uses of the selected scan data. On the left side we see two colored versions of our material, one with a flat appearance and one with a more 3D appearance. We can discuss later why we need sometimes a more flat and sometimes a more 3D version. On the right side you see two versions of a 3D depth map, a grayscale and a black and white version. We need this depth map files for embossing. We can discuss later why we need sometimes a softer and sometimes a harder version, or why we split them into slices. In case of producing only the color, we can use in all processes the colored version with more 3D appearance. The technical separation for colorways can be very different for various processes. Since we usually have no problems with mismatching in digital printing, we can use both versions of the color, with the more flat or with the more 3D appearance. This is a matter of taste. In the traditional laser etching process and in digital printing single pass with digital embossing, we usually use the black and white version of the depth map. In traditional embossing applications, for example engraving with laser direct, and in multipass printing applications, we usually use the grayscale version of the 3D depth map. Here we get the best results for 100% reproduction of a surface. Because of mismatching in this process, we mostly use a slightly flatter version for the color to avoid duplication effects caused by the printed shadows and the shadows created by embossing. In this case, we use the color and the depth data to produce a 3D prototyping on a Roland multipass printer. Now we know the different uses of selected scan data, and so we will start with optimizing the scan data. For this, the Metis Light Inspector starts automatically direct after scanning. This is now the interface of the Metis Light Inspector. The software starts automatically after scanning. Here we see two planks of the material. We see we have now an empty custom setting list here. We have no settings. It's what we see is a flat light version of the color. If we go inside, we have no shadow and highlights. So I make a version color flat. This is the first version. Then I make a little bit a version, a moderate version from top light that we can use also as a with a more 3D appearance. I will push a little bit the shadows here, and I do that. Okay, we can control it very good here. So I make here a color 3D appearance. Then I go to recalculate the depth data. We have now the depth data here. This is a grayscale version. We can use it for the laser direct engraving and multipass application. 3D depths. Okay, and then for the application single pass, digital, we make it more flat and more hard. That is, I think, a little bit. In this case, we make a 1-bit version. We must not do only a 1-bit version in single pass. We can also do a 8-bit, because single pass can also use more than 1-bit information, but that we can discuss later. So I make this black-white 3D depths. Okay. Now I have here a setting list with black, white, standard 3D depths, this, the color 3D appearance here, and a flat color. So what we also can do is we can evaluate this data inside of a real-time 3D window. Now we see this. I change this here a little bit. If we want to show only the 3D depths, then I change a little bit here this parameters. So this is the information you normally get from the grayscale 3D depths map. We see we have horizontal and also a very fine vertical structures here, very good. We can push that a little bit. I do that. Now we have a little bit more of these structures, because in a normal process it will not be 0.8 millimeters depth, it's more 300 microns, and then it is helpful if we have some structures here. So if I go back, we get a little bit correction here, and I save it one time more in the standard 3D depths. I override it so that I have this information. The same we can do to evaluate this with the embossing data for single pass. We go also back in this window, and we see if we make a lighting here, we got more harder information here. It's very fine, I know that. Go inside 100%. In combination of this, we have a little bit the feeling for this kind of embossing. It's very hard. There are possibilities to make it smoother. We can do that. I smooth it here, the information. So I have to evaluate the data for the single pass. I have now a good feeling what I got if I make a digital embossing with this data. The data we put it inside of the process in hard, and we know they can make it not so hard. It comes more like this. And so for many design studios, it is a fixed procedure not to consider the raw data or the layouted image composition only on a planar surface. So we see the possibilities of our raw scan data, or of a complete new, in this case, all-over decor. With specialized software, you can see your raw data, for example, under different light situations. After optimizing, the data is passed on to the post-processing. Here retouching is carried out, among other things, and layouts, technical separations and colorways are created. AVA or Photoshop is usually used. A benefit with AVA is that color and embossing data can be processed simultaneously. This is also important in our test production as it is an embossed in register production. So let us hear how you can do this in AVA.
Thanks, Jürgen. Thank you very much for that, Jürgen.
Yeah.
Okay, so we're going to pass over to Rachel. Some of you know Rachel. Rachel's going to show you how this all this valuable data is edited in AVA. Just to pick another point that Jürgen made, I mentioned Photoshop. AVA works very nicely with Photoshop. It's a complementary application. But for the next 20 minutes, 20 minutes, we're going to show you how the AVA software edits the data. Whilst Rachel's just taking control of the screen, about 2 years ago, we started to develop an application for 3D, primarily for embossing, but we quickly realized it had a lot of opportunities for all markets which produce products with texture, with 3D texture, whether it's ceramics, even rugs and carpets, potentially textiles, and certainly with the addition of the Roland for the rapid prototyping, the software we have now makes speeds up the process and puts the power of 3D design in the hands of the designer as well as the producer. And what we unveiled last year was a version of our 3D software which imported the native Metis data, and that was a game changer really, because that if we can import that data, that compact data into AVA, it gives you a huge head start. And what Rachel's going to do is going to show you how our software is pretty unique in the fact it will edit the 2D and 3D information simultaneously. But Rachel's really going to focus on the area. If you're interested in creating and then registering emboss or in registering texture with the main design, that's possible, as well as anything which is non-registered is also possible. So over to you, Rachel.
Thank you, Duncan, and thank you, Jürgen and Massimo. So I have the document here, and you'll notice, as Duncan said, I have imported the height map, the glossy contents, and the image. So AVA opens all of that data in one go. So I think this design really lends itself to being made into a plank layout. So that's what I'm going to do. And you'll notice here that I have some saved selections within the document. So a bit of preparation has been done. So I'm just going to drag a selection in, and this marks out the area that I want to create my first plank from. So I've got my selection, but now I need a new document to put it into. So I'm going to click this button here, and it's going to create for me a document which is in repeat. This blue frame here indicates the first repeat of this document. And I do actually have a grid on here just to help me with the placement, okay? I'm not gonna work with it visible. I am gonna turn it off, but it will still be active just to help me with a little bit of placement there. So I come back into the original scan. I'll copy that and I will paste it into here. And then I'll just change my tool. So I'll just indicate that I can move this straight over that repeat join, and you can see it changing down here too. Okay, so just play around with it, position it nicely. So I'm just going to repeat that for the next 3 planks. I'm going to put this one down here, and again put it right over that repeat join, all the while seeing it down here too. and I'm taking all of the data with me. So you'll notice that all of 3 layers. Now, you may need to move our faces down either to the bottom of your screen or to the left to be able to see my layers palette here. I think the default for Zoom is to put us on the right. So if you just move us over, you'll see my layers palette here. So I'm copying all of the data in one go and just pasting it all in so you can see all of these layers coming in here. Okay, slide that one across there. And again, I want to just move that one over there. And I'll just take the last one in. Paste that in. Pop this down here. And I can flip these and I can, you know, flip horizontal, flip vertical. I think I'm flipping the whole design there. Didn't mean to do that. Oh no, there we go. Okay, so we can flip them, move them. And then I can see if I open my repeat inspector down here, I'm in a 2x2 repeat at the moment, but I can increase that to as many repeats as I like. So that I can zoom out and I can really get a feel for how this document is starting to look. And I can continue to move these items around as it's in repeat. Oops. Okay, so jumping forward, because there's timing that we have to stick to. Jumping forward, I'm just going to open up the final product, if you like. So all I've done here is I've tidied up the layers palette and I've added a bit of ground to make it look really nice. But now what I want to do is I want to visualize what this is going to look like as a product, as a 3D tangible sample. So just slide that across there like so, and I'm going to open up my structure simulation window. So this initially gives me an indication of what it's going to look like. Okay, just zoom in there. And you can see that I've got my height map there. I can change the lighting. Okay, change the angle, change the zoom. But I can also view this using different profiles, so to speak. So if I click down here, you can see how we can add more information to this product. So we can change the gloss intensity, the material roughness, and if we have an engraving curve, we can also put it in there so that we can get a true indication as to what this product's actually going to look like in production. So I have 2 saved versions over here. I've got a chemical emboss, so I can apply that, and I've saved it with a preset angle, if you like, and then I've got a laser one. So again, you can see the curves change here, the gloss intensity changes a little bit, but I can still spin that around and I can change the microns down here to reflect the amount that it's going to be engraved at. So that's 300. Now, most importantly, I can view this structure without the image on top, and that means I can get a real good look at it and start to see if there's any problems that are going to appear in production. Now, the first thing I'd like to do is I want to remove the gloss and the height map from the ground. So I'm going to pop back over into my 2D view and I'm going to make a snap selection to the ground. And then I'm going to just activate my height map and gloss, and I'm going to take that away, and we'll see the grout appear in our 3D view like so. I'm then going to work into this a little bit more. So I'll view the depth. Obviously the gloss is there too, but I'm really working on the depth, looking at the depth. And I'm going to start finding some faults that need correcting. So I'm going to use this tool up here called the fault finder. And what this does is it enables me, you'll notice that I've got a relative cursor, one in the 2D and one in the 3D window. So as I move my cursor around, I can click down and that will put a small red circle on the 2D where I want to correct that. So I know where to come into later, if you like. So I can just go around and mark the areas that I'm not too happy with. And then I can come into the 2D and I can start zooming in on the areas that I want to fix. So that will zoom right in to the 3D window. And I can move this around. So I find this a little bit rough, and then around the edge, it's a little bit too smooth. So I want to just even it all out a bit. So I'm going to start by taking a selection of the height map gloss layer, and I'll just make a little selection here. And I'm going to drag that up to cover over this area here. Now you'll notice that I've forgotten to actually copy the data, okay? So even though it's replaced the data here, you'll see this big hole here. So the real-time editing is very obvious there. So this time I'll undo that and be a little bit more careful. And I'm going to zoom in to here, and I'm going to copy and paste it this time and put it right over there. So I'm just going to turn this layer off because I know I've managed to find the area that I want to fix. And then I can flip the data around, get it to sit nicely. I can rotate it. And to blend this copied area into the original a bit better, I'm then going to use a carbon copy. So I'll go over to my pre-prepared carbon copy tool, and I'm just going to start copying some information in here. And you'll notice that as I do this, the information in the 3D structure also changes. Okay, I can also dodge and burn the information. So I can lighten some areas. So in AVA, the whitest area is the lowest point on that height map, and the darkest areas are the highest on the height map. Okay, so I can come in here and I can dodge and burn this. So what I'm going to end up with is actually a very contrasted area in my 3D view here, and you can see that as I move around like so. Now, jump forward, I've corrected all my areas, and so I want to go back to viewing the design as a whole. Okay, so again, we can just take a look at this structure here, and we can put the image on like so and just get a feel for that corrected information. Now that I've got the design in repeat and I'm happy with how the height map and the gloss are looking, what I then want to do is I want to further develop the design by separating it. Now I'm going to separate this using an automated separation tool, just because we're against time, although we do have these tools that separate quickly, and they separate for digital, just so that I can get an idea of what this design is going to look like with some colorways in. We do offer an array of separation methods which can help you prepare your designs for engraving too. So I'm just going to use this button up here, and this is going to very quickly separate this wood grain for me. So you'll see in the layers palette here, it's creating 3 layers, doing the separation. It's just going to flip the layer order there for me too. And then I can continue to edit this if I like. So I just want to gamma the information just a little bit, just to make it look a little bit better there. And then what I'm going to do is I'm going to load in some colorways. So colorway, load colorways. And these are colorways that I've pre-prepared, okay? So I'm going to load those in. So we'll see up here that we've got another 5 colorways. So what's really nice about this is I can now go back into my structure simulation window, and I can view what this product's going to look like with these colorways in. So I can start to flip through those. Just go back to my default view. Okay. And then I want to try one more thing with this. I've got an in register emboss here. I just want to see what it's going to look like now with an all over emboss. So I'm just going to load in a layer. So that's going to put that in there. Oops, excuse me, just clear that. And then I'm just going to activate that. And you can see, let me just make this full screen. We can zoom out a little bit and you can start to see what that would look like with an all over. And again, we can change the microns, change the lighting, and of course we could edit this structure too. Okay. So now that I'm really happy with the development of this file, I want to lay it out and present my ideas. So I'm going to go back into this window and I'm going to open out a presentation page. Turn that off for now. So I'm going to open a presentation page. I'm going to load in a template that I use regularly. Now I'll just have to turn off these layers, let it load in. So it's just loading in some embedded files. So I'll just click on here.
I really like the text you use, Rachel. And just for the audience, so you can use the Metis scanner to scan in a variety of different structures and textures and have those in your structure texture library and experiment with different embosses to accompany the main design. You could, because the height map is actually a grayscale, either 18-bit or 16-bit, you can also create your own structures, and as a designer, you can experiment with those in the CAD system. And the next step of the presentation will be the Roland, where you can proof it out and potentially sell product based on a digital sample. Over to you, Rach. Thank you.
No problem. Yeah, so I've got my presentation here now. So I've got down here, I've got the idea for my repeat. I've got some ideas for colorways down here. And I've obviously got the design in its 3D state, if you like. So the only thing now that I'm really missing is a tangible product. So this is where I print it onto a Roland printer. But I just need to prepare that file to be printed. So what I need to do is I need to send it through our splitter technology. Now, if I just open that up for you, this is the technology that we use to pass the information through, determining how many layers to split that height map into, okay? How many layers of white will be printed, and Stefan's going to explain why we print white in a bit. So we process it through this application here, through our digital print rip, and then we end up with this type of information here, which we then send on to the Roland printer. So I'm going to hand over to Stefan now.
Yeah. So we'll just give Stefan a moment to take control of the screen. Thanks, Rachel. That was fantastic. So at this stage, everybody, if you do have any more questions for the panelists, you can use the chat system and the QA system. And I believe you should be able to send individual questions to individual panelists on a one-to-one basis rather than public view. So feel free to use that whilst we are getting ready for Stefan. Okay, Stefan?
Okay.
Great.
Thanks, Rachel, and a warm welcome to the audience. First of all, I want to say thank you to the previous speakers for their presentation of the hardware and all their software tools that makes our life so much easier. And I have to admit, I'm really happy about this partnership, because wherever you find a Roland printer used for this application, the chance is very high that you also find a 3D scanner from Metis. And with AVA, we have now the perfect connection between the Metis scanner and the Roland printer for the output. So my name is Stefan Höfs. I'm a business development manager at Roland DG. And what I want to show you today is how to bring all the digital data we have created so far back to reality. Because in the end, what you really need to understand and to experience a product or an object is something you can hold in your hand and see it and touch it. So, before I start explaining the solution in detail, first some words about Roland DG, just that you know who's talking to you. So Roland DG is one of the leading manufacturers of large form printers. It's founded in Japan in the year 1981 during the first digital revolution. And our goal was always to create digital solutions that make our life or the life of our customers easier. Today we have an installation base of about 150,000 printers around the world. We are available in more than 200 countries and have a net sale of about 340 million euros. Besides being one of the market leaders in the sign industry, we also offer all kinds of dedicated solutions for all kinds of industries. And the haptic proof is one of these solutions. And now we will go into detail. So to understand how it works, I have first to explain a little bit how digital printing is working. I will do this very roughly. And it's very easy. What we have here is we just have a table moving from the back to the front. And at the same time, we have a printhead jetting from the left to the right, from the left to the right, and at the same time, spitting ink on whatever object you have placed on the table. The ink we are using for this application is a so-called UV ink. That means this ink cures when it is exposed to UV light. That is why we have attached a UV lamp on the left and on the right side of the printhead. The advantage for us of the UV ink technology is that you are able to print very thick ink layers, and that's what we need to build up a tactile structure on our substrate. The colors we are using is CMYK, like on the desktop printer at home to print all the color information. But besides this, we also have a gloss ink and white ink. We use the gloss ink to print in multiple layers the structure, the haptic surface. And we use the white ink just to make the colors a little bit more bright, because after printing the haptic structure with the gloss ink, you see that this is a little bit yellowish, and then it is needed to first print a layer of white ink. The printheads we are using are able to print very small dots to achieve the resolution we need of about between 3 and 5 picoliters. And the thickness, the maximum thickness of one layer of varnish is a little bit depending on the printer between 30 and 60 microns. But it's also possible, for example, if you wanted to print leather surfaces where you have a very fine structure, to print with a thickness of only 10 microns, for example. So before I show you a small video that makes the process more clear, I just wanted to review a little bit the pre-press process we have seen so far. So everything started with the Metis scan, which delivers, for our purpose, delivers us two important outputs. First is a black and white picture representing the height topography of the surface of the scanned object. White is representing the height 0, and black is representing the maximum height. And on the other side, we have the high resolution RGB color image that we use to print all the color information on our substrate. Before doing this, there's AVA in between. With AVA, you do all the manipulation of the scanned data to your wishes. And AVA is also able to generate all the files you need to send to the Roland printer and to print the haptic surfaces. This was different a few years ago. At that time, it was all manual work with Photoshop. So today it's a lot easier to process the data and make them ready to print on our devices. In the middle, you can see the end results, first of printing all the layers of varnish. In the middle, you see then the printed structure with a layer of white. And at the bottom, you see the final product with the color information printed on top of the structure and the white. And now I will show you the video. So this is our showroom here in Village. And you can see the LEF series. These are small flatbed printers, which are very often used for this application. But we have also bigger flatbed printers. And some companies are also using bigger flatbeds from Roland to do the same application. So everything starts with the first gloss layer. What you see now is the normal speed. Most of the video we see fast forward, so that the complete video has only a length of 3 minutes, even if the process in real time takes about 1 hour. So for this sample, we have a size of A4, and we printed a height of about 600 microns. So it means we print 9 layers of varnish, each a little bit more than 60 microns height. So this is the first layer. I will then only show the fifth, I think the third and the fifth layer. But in reality, these are 9 layers of varnish. So now you can start seeing the structure. With the fifth layer, you can already see a lot of the wood structure. Next layer will be the white.
Stefan, can I just ask a quick question on behalf of a viewer?
Sure, Rachel.
Can you explain the minimum and heights, the minimum and maximum heights that you can get from the gloss layers?
Yes. Actually, we have one printer equipped, in this case, one printer with 2 rows of 180 novels equipped with the gloss ink. And if we print out the maximum dot size with both ink rows, the height is about 65 microns. But it's also possible to linearize the output, like you linearize the color to the density. You can linearize the output of the gloss ink to the height. And so it's possible to reduce the ink to the thickness of your wish. And especially for really fine structures like leather, this is also needed.
Thanks, Stefan.
So here we see the close-up of the structure. So in most of the cases, your structures will not have a height of 600 microns. Mostly it will be a smaller height, also due to your production tools, but it's possible to print even higher structures. 1 hour sounds like a long time, but I will shortly tell you about our first customer who requested a proof of a structured wallpaper. It's about 8 years ago. And he requested a sample with a size of 1 meter to 70 centimeter and with a height structure also of 1 millimeter. And we really managed to make a very good, to print a very good structure, and also the colors were good and were matching. And also the customer were really happy with the sample we printed him. And then the customer asked us, how long have you printed on the sample? And we were a little bit ashamed because we were not used to this long time, and we answered 8 hours. But the reaction of the customer was, what? Only 8 hours? We normally wait for weeks until we have a 3D proof of our final product, and it costs us a tremendous amount of money. So it was really that time when we recognized that we found a proofing solution for all the companies producing decorative, tactile surfaces. And today we are we have an established technology. First, we were successful in the wallpaper industry, but very short after the wallpaper industry, the flooring industry was following. And we have also some installations in the automobile industry. There they use this proofing technology mainly to proof the leather optic of the car cockpit. Our customers are using the solution a little bit in different ways. Some are using it in the design process. That's what we have shown you today. Some of them are only using it to make a final proof before creating production tools, which is very expensive. And some of them are only using the digital solution to print the haptic surface without color information. And then they are using these short-term press plate to produce final structure on a print that is done with the mass production printing technology. So this is the way our customers are using the solution. The advantage is that it is very flexible. They can react very fast on complaints of their customers and change things in the design in a quick way. Another important thing is that they don't have to give data to third-party companies to make proofs. They can do it in-house. That's also very important for these sensitive design data. So I wanted to close my presentation with showing you our product portfolio for this application. So we have different printers, mainly different in the size, starting with a width of 50 centimeter up to a width of 1 meter and 60. The length is not that important. So with the 1 meter and 60 machine, it's no problem to print in lengths, for example, 3 meters. We are using special fine art print heads in this flatbed printers to achieve the resolution we needed, because in this case, it's most important to be as near as possible to the mass production product. That's more important than speed. And what is also common with all of our printers, they are completely integrated in the workflow with Metis and AVA. So these are my last words. Thank you very much. If you are interested in our products, please don't hesitate to contact us.
Thanks, Stefan. That's terrific. Whilst you were talking, questions were coming in about the Roland technology, and Rachel's been answering those very well. One question came in about, can you print without gloss and just matte? And I know from experience you can, and you can also be selective with the matte and the gloss. When we were working with your printers, we were asked questions about having gloss in the low parts of the print and vice versa. And we've been showing customers for a while how you can do that, be selective with the gloss. But would you like to comment on the matte gloss question?
Yeah, I can. First of all, we are using it's also possible to build the structure with the colors or with the white ink. But we use the varnish because it's most sharp and you get the best results. But you can also print the varnish, the gloss ink in different ways. You can print it as a matte ink. That means that the UV lamp is placed next to the print head, or you can use the gloss ink to really print a gloss effect. To achieve this, you move the UV lamp a little bit in front, so that the UV gloss ink has time to flow out and you achieve a gloss effect. You have to experiment a little bit with it to achieve the perfect gloss effect you need. If you print too much gloss ink, you can have the side effect that you fill up your printed structure. But you can also print multiple thin layers of gloss ink, and with playing around with the gloss and the matte ink, you can achieve a lot of different effects in glossiness and matteness.
Okay. Thanks, Stefan. You've had another question asking if the printer is capable of printing 4 or 5 millimeters of depth.
In general, yes, it will take really a long time. So for A4, 600 microns, it was now 1 hour. So 2 hours, 1.2 millimeters. So 10 hours, A4.
Okay.
But it's in general, it's possible, but you need really a stable plate below the print, because else you will get tension and the plate will bow. I have never done it, to be honest. So the maximum height I've ever printed is 1.5 millimeter.
Okay. Yeah, and he's obviously got to consider the width of the printer. For the attendees, a number of AVA customers are using the Roland printers to make prototypes of different widths. We have one of the small models in our studio, but some of our customers have the wide format. And that's important, particularly because the Metis scanner, you can do a one-to-one ratio from the Metis scanner to the actual output with the wider Roland printers. And obviously AV software can handle that size of data. But if you're wanting to show digital samples to customers, then certainly the wide format machine is being used and is viable. But some people also jigsaw various small tiles together if they wanted to show someone, give someone the idea of length and breadth. Okay, so we have overrun by 4 minutes. Rachel, would you mind just showing the final slide? I'm going to share our contact details with everybody. Please feel free to contact us for more information, personalized demos from the 3 vendors. But from myself and the panelists, thank you. Terry, I'll answer your question in a moment. Yeah, thank you so much for your time and attention. I hope it's been a valuable webinar. We'd love to have your feedback. And yeah, once again, thank you very much. And thanks to our partners at Roland and Metis for your support.